Okay, so for 11 and 12 and 13, I'm going to just talk it out a little bit with you guys. We have already gone over a few of these, how to do the picture, the equation, and solving them. So 11 is similar to 10, where you have to add up for example, it says 11 says the table below shows the deposits Miriam has made to her savings account. If her deposits totaled $305, write and solve an equation to find the amount of the missing deposit. So the first thing to do is to consider how much are these deposits together that's already been made. And then you're going to want to subtract that from 305 so that you can find that last deposit. So that means whatever the total of these deposits are plus X will give you a total of 305. Okay? All right, so let's look at number 12. Devontae has a large alternative rock CD collection. He loaned out 24 of his CDs to his friends. If he has 35 CDs left in his possession now, how many alternative rock CDs does Devontae have in his entire collection? All right. So you know that what he has left is our equal. So that's 35. Okay. So whatever he had originally is our X. And it says he loaned out. So we have to ask ourselves, if he loaned out, am I adding or subtracting? Well, if I'm giving something to someone, I'm taking it away from what I have. So that means I'm subtracting. So that means I have the X amount of CDs minus my 24 that's loaned out. And then I have 35 less left. So X minus 24 equals 35. And you could draw a cool picture there. You could write that equation and then solve it to get what's left in his how much he had in his collection to begin with. Number 13. Lorena spent her birthday money on a DVD that costs $14, a new sweater for $18, and a mini digital camera for $34. The tax on the total purchase was $5. If Lorena received $9 back in change, how much did she give the cashier? All right. So the cool thing is that we can add up the total amount of her purchases. All right. And so that's the $14, the $18, and the $34. And then we have to add the amount that was taxed, which is $5. And we get whatever that number is. So we know that what she was given back is $9. So that's our equals. So we have to find out the original amount. So that's X. And then we have to, when we're giving someone money, we're taking that away from what we have. So this is a subtraction problem. So it'll be X minus the total of her purchases and tax equals 9. And then we would solve for X. All right. And notice that it told you here that it is a subtraction equation. So that was a big hint. All right, let's flip the page to 14. Okay, 14 says it takes Imani 4 times as long as Carissa to travel to school each morning. If it takes Imani 28 minutes to travel to school, how long does it take Carissa? All right, so it says draw a picture, write a multiplication equation, and solve the equation to answer the question above. So I'm going to pause and solve it and start writing out my picture and my multiplication equation, and we'll come right back. All right, so it says that it takes Imani 4 times, and times is a key word for multiplication. So besides the instructions telling you to write a multiplication equation, we know that we're going to multiply because of that keyword. So it takes Imani 4 times as long as Carissa. So whatever Carissa's time, which I'm going to use for T, 4 of those will equal what Imani has. So, and we know that it tells us that we have, if it takes Imani 28 minutes to travel to school. So we know 4 of those t's is going to equal 28. So I have here, that will be our equation of 4t equals 28. So now we're going to solve this using our one-step equation strategies. So the first thing I'm going to do is I'm going to point to my scale. And now I'm going to circle my variable. And I can ask myself, what's being done to that variable? Well, it's being multiplied by 4. So the opposite or inverse operation of multiplying by 4 is dividing by 4. So I'm going to divide both sides by 4. So now I'm going to cancel out these 4's, and I'm left with t. Okay? And now I have to simplify this side. 28 divided by 4 is 7. So that means that t equals 7. And remember that t was the amount of time it took Carissa to travel to school. So it takes Imani 28 minutes, and it only takes Carissa 7 minutes. So now it says to explain your reasoning, okay? And you can write down the process that it took for you to find it. For example, we talked about how if Imani takes 28 minutes, and that's 4 of our t's, right? Because it says it took her 4 times as long. Then that means that once we solve it, we find that Carissa only took 7 minutes. So you could write out basically how you got to that reasoning. All right, so now we're going to look at the next section. The next section is solving inequalities. And this is a section that we're really going to need our strategies for one-step equations. And that's how we're going to solve these. And then we have additional questions for each one. So I'm just going to do a few of these to give us an example of what we're looking for. Okay, so for number 16, it says h plus 12 is less than 36. So we're going to solve that. Then we can answer the next question. It says, is 30 a solution? So our first step will be to solve this. So we're going to now notice that we have an inequality symbol. We don't have an equal, but we're going to use the strategy as if we do. We're going to point to our inequality symbol as our scale. Because what we do on one side of the inequality symbol, we're going to do to the other side. And then I'm going to circle my variable. So I have h plus 12 is less than 36, and I want to isolate that h. So I have to say, what is going on with that? Well, 12 is being added to it. See there, plus 12. So now I'm going to subtract 12 on both sides. It's not a lot of space there. So I'm going to move over to the side. So these 12s cancel out. And now we have h is less than, and we have to simplify. 36 minus 12, and we know that to be 24. All right. So it says, so we know our solution is h is less than 24. So whatever values that we can come up with, whatever solutions we could say h represents, they have to be less than 24. So now the question asks us, is 30 a solution to the inequality above? Well, 30 is not less than 24. So 30 cannot be a solution to the inequality above. So I'll circle no. It says, how do I know? Well, this is where you get to explain how we know that 30 is greater than 24, but the inequality requires that h, whatever h is representing, whatever number, that it be less than 24. Okay, so after that, 17, 18, 19, and 20, they ask for you to choose 3 numbers that make the inequality true. to choose 3 numbers and make the inequality true. So I am going to, let's do numbers 18, and then I'll do number 19. All right. So for 18, D minus 5 is greater than or equal to 7. So I am going to do my one-step equation strategy. Okay, so I pointed to my inequality symbol to use as the scale for both sides. I circled my variable of D, and I noticed that 5 was being subtracted from it. So in order to make that 5 disappear, I had to do the opposite or inverse operation with 5, and that was to add 5 to both sides. So then I was left with D is greater than or equal to 12. So now it's saying to choose 3 numbers that will make that inequality true. So whatever number I choose for D, it has to be greater than or equal to 12. So that means for one of my numbers, I can use 12 since it says that it's equal to. I can use, how about 18, because that's greater than 12. And I'm going to use 40. That's another number that's greater than 12. So we have our greater than or equal to the 3 numbers that are greater than or equal to 12. All right, so now let's look at number 19. Number 19 says 15p is greater than 75. 15p is greater than 75. So we're going to use our one-step equations strategies and then pick our 3 numbers. Okay, so I circled my variable, I pointed out my scale, and I noticed that 15 was being multiplied by that variable of p. So in order to isolate the variable, I have to do the inverse operation. So if it's being multiplied by 15, I'm going to divide both sides by 15. Those 15s on the left side with the variable, they canceled out. Leave me with just p is greater than, what I simplified, 75 divided by 15 is 5. So p is greater than 5. So when I choose my 3 numbers, I'm choosing 3 numbers that are greater than 5. So bigger, higher, more than, however you want to consider it, greater than 5. So let's choose, I'm going to choose 7. I'm going to choose 10. And I'm going to choose 17. Those are 3 numbers that are all greater than 5. And I just want you to think about this. When you think about whether or not it makes the inequality true, you have to say 15 times my 7, does that give me more than 75? Yes. 15 times 10, does that give me more than 75? Yes. 15 times my 17, does that give me more than 75? Yes. So we are looking for values of the variable that will make it true for this, that p is greater than 5. All right, so now let's look at number 21. Number 21 is a divided by 2 is less than or equal to 6. So I'm going to point out my scale. And I'm going to circle my variable. All right, so we have to ask ourselves, what's going on with a here? Well, it's being divided by 2. So if it's being divided by 2, the inverse operation of dividing by 2 would be to multiply by 2. So I'm going to multiply both sides by 2. Remember, we want to keep that balance. So on this side, these 2's cancel out, leaving us with just a is less than or equal to, and 6 times 2 is 12. So whatever our a is, whatever number a is representing, according to our inequality, it has to be less than or equal to the number 12. So our question is 3 a solution to the inequality above? In other words, can a equal 3? So if I was to substitute 3 in for A, would my inequality still be correct? Is 3 less than or equal to 12? 3 is indeed less than 12. So 3 is the solution. All right, we are going to turn the page. All right, so for these on the back side, 23, 24, 25, and 26, they have some graphing done there, and they want you to select the graph that matches the inequality. So this is where you had to use your number line skills. So the first thing we have to look at is what number are we comparing our variable to? And that's the number that we're going to have selected at the graph. So let's look at number 23. So we have our variable j, and the number is being compared to is 0. So we know 0 is right in the center there. Notice all of these are at 0. So that's our first step. But we have to now look at our inequality to see, our inequality symbol says that it's equal to. So it's greater than, j is greater than or equal to our 0. So we know that that means a closed circle. Remember our notes. When it has the line there that tells us it's equal to, that means that our circles are closed. See that? So we have to now look at the ones that are closed. So we can automatically eliminate any answers that do not have closed circles. So B does not have a closed circle. So we know that's not an answer. And D does not have a closed circle. So D is not an answer. So now we're just looking at A and C. Now we have to say, this is greater than. Notice that it points like our arrow. So it's greater than. And remember in our notes, our handy dandy keyword sheet, when it is greater than or equal to, greater than means we have some growth. That means we're going in a positive direction. We're going to the right. All right. So we are going to make sure we have a closed circle and our arrow or our graphing is going to the right, our shading. So let's look at our two options. A is a closed circle and it's going to the right. Great. C is a closed circle, but it is going to the left. So C is not an option. A is our solution there. All right. So now let's look at number 25. Number 25 is n is greater than 3. So we know that there's no line under there. So it's not greater than or equal to. So that means that it is an open circle. So any solutions that have any options here that have a closed circle, not even a chance that it's our answer. So let's look. A has a closed circle. That's wrong. C has a closed circle. That's wrong. So now we're left with B and D. So now we have to say, all right. So, and notice that all of them are already at 3. So we're good there. Now we have to ask ourselves, well, which direction does my shading or my arrow go when n is greater than 3? And remember, and I'm going to keep referring to these because you're supposed to study, when it's greater than, but not equal to, say greater than, our circle is open and it's growth. So it's going to the right in the positive numbers. So let's look at our graphs to see which one is going to the right. D is going to the left, so that's not correct. So we know our answer here is B. All right. So now, number 26. Number 26 and number 24, you would do those the same exact way. H is less than 0. So that means that I'm going to look for open circles. All right. So I'm going to cancel out this one because that's closed. I'm going to cancel out that one because that one has a closed circle as well. And less than, that means I'm not growing. I'm going into the negative direction. I'm going to the left. So B is going to the right. So that's not an option. So my answer is D. In 26, Y is greater than or equal to 3. All of my numbers here are aligned at 3, so that's great. And because it's greater than or equal to, I'm looking for a closed circle. So any that have open circles, they cannot be my answer. So B has an open circle. See, look at that little circle is open. So that's not an answer. And D, open circle. That's not an option. And Y is greater than or equal to, so that's growth. So that means that of our remaining solutions of A and C, I have to look for which one is going to the right. And A is going to the left, so that's wrong. So my answer is C. All right. So this says write an inequality for each scenario below. You must do more than 30 jumping jacks, is what 27 says. You must do more than 30 jumping jacks. So just for the sake of everyone being on the same page, let's use X for a variable. All right, so we're going to use X for a variable. So you must do more than 30 jumping jacks. So whatever amount that you do, that's our X. We don't know up front how many you're going to do. So whatever amount you're going to do, they must be more than or greater than. Remember our keyword? There it is right there. More than. See the symbol we're going to use? So must be more than 30 for 30 jumping jacks. All right. Number 28, the stadium will hold at most 25,000 people. Okay, so on number 27, I kind of skipped a strategy that I wanted you guys to do. I apologize. I want you to always underline or circle the keyword or phrase that helps you understand or gives you the hint that which direction and which inequality symbol we're going to use. So in 27, our key phrase was more than. Let's see for number 28. Our key phrase for number 28 is at most. So at most. And so I have to ask myself, so the stadium will hold at most 25,000 people. Okay. So that means that I can't have more than 25,000 people. And if I can't have more than 25,000 people, that means the amount of people that I can have, which is my X, has to be less than, but it says at most 25,000 people. So that means I can have 25,000. I just can't have more than that. So I can have, so my X, the number of people I can have has to be less than, or it can be equal to 25,000. And the way I just thought that through, I had to work it out and process how to think. That's what you have to do for these. So that you're not going to have your keyword notes with you on the test. But this gives you the ability to try to think. If I have X amount of people and it says at most, that means I have to have less than. Or I can have the same amount of 25,000 people. So that means that I have to have less than or equal to as our inequality symbol. So now let's look at number 29. People under 16 are not allowed to drive. People under 16 are not allowed to drive. So our key word here will be under. So I'm going to underline under. And so that means whatever your age is, and it's important that we try to think of when you're trying to write the inequalities that you consider what our X is representing. And our X here is representing the ages of the people. So whatever your age is, if you are younger than, or if your age is less than 16, you are not allowed to drive. So that inequality would be X is less than 16 for not being allowed to drive, right? So that means if I wanted to do an inequality to be able to drive, my inequality would be your age has to be greater than 16. But it just says that people under 16 are not allowed to drive. That means if you're 16, you can drive. Okay? So it would be in order to drive, your age, X, has to be greater than or equal to 16. So people under 16 are not allowed to drive. So if your age, X, is less than 16, you are not allowed to drive. That means to drive, your age, X, which is represented by X, has to be greater than or equal to 16. All right, and number 30. Children are at least 36 inches tall. Children at least 36 inches tall can ride the go-karts. So our key phrase here is at least. All right. And at least tells us that, so if I'm a child, I have to be 36 inches or taller in order to ride the go-karts, which is pretty cool. So that means that my X is going to represent my height. So whatever my height is, it has to be greater than or equal to 36 inches. You see that? All right. So now let's look at these. Let's talk about this extended response. All right. Vivica is hiking through the national parks during her vacation. Her journey takes her 490 miles to complete in 35 days. All right. Write a multiplication equation to represent this situation. Solve the equation. Explain and justify your answers to part A and to part B. So there are a couple key pieces of information. Her journey takes us 490 miles to complete in 35 days. So we want to know, perhaps, what does that mean for how many days, how many miles did she go per day? That's what we want to find out. So let's see what that would be. That would be 35 days. We're not sure how many miles per day she did. So that's going to be what we use for X, that unknown quantity. But we know the total miles she did is going to be 490 miles. Right? So we have our equation here of 35 days times a certain amount of miles per day will give us 490. So this brings us back to our one-step equations. All right. So we are going to point out our scale. Then we're going to circle our variable and ask ourselves what's going on with that variable. Well, that variable is being multiplied by 35. So the inverse operation of multiplying by 35 will be to divide by 35. And remember that scale, we have to divide by 35 on both sides. All right. So the 35s on this side, they simply cancel out, leaving us with X equals. And now we have to simplify 490 divided by 35. And I'm going to pop that into my calculator. And I get that 490 divided by 35 is 14. All right. So that means that if she does a steady amount each day, she's doing about 14 miles per day. All right. 14 miles per day. So our x equals 14. All right. So we've written out our multiplication equation. 35x equals 490. All right. Then we solved that equation for x, and we see that x equals 14. And then this is explain and justify your answers to part A and B. This is where you get to explain your reasoning for how you got to 35x equals 490, and I have already explained that. And then for B, you get to explain how you used your strategies to solve. All right, and that is the end of our study guide. Thanks, guys.